Hello everyone, I'm Vivek from K4 Metrics and we support the software SmartUQ in India. So we'll be doing a series of short videos and the agenda is to address if we can reduce the number of simulation runs. Now simulations are a well established technique and is a valued asset to a designer. In order to have confidence in the design, there is no choice but to go with different studies, and this leads to performing large number of simulations, which in turn is time consuming. So, as I mentioned, we will be doing a couple of short videos on how you can avoid performing large number of simulations. So, when you think of reducing the simulations, the questions that come to our mind is how many sampling points I need to consider to cover the design space, how I can reduce my simulations, and doing so if I am trading off accuracy over time. Now, before going ahead, let's look at what is design space and what are sampling points. So, we can easily visualize a surface in 3D space. The independent variables are xy coordinates, the dependent variable is the z coordinate. The equation of the surface tells you the value of z for any given x and y. If we do not have an equation for the surface, we sample the surface using a coordinate measuring machine. Then use that sample as a representation of the surface. So how do you know how many points to sample at and whether you have missed any features? Similarly, any situation that has inputs and outputs is a design space. So you want to know the output variable at any given combination of the input variables. A DOE or design of experiments is a way to sample the design space. As I mentioned earlier, we'll be addressing all these points over a series of short videos. The statement of our problem is to do CFD simulations that help in trajectory plotting. The reason we chose this problem statement is because in order to get reliable trajectory plots, the number of simulations to be performed can be high. So to outline this process, we have selected a simple case. So Naka airfoil 2D inviscid flow. The point to note here is that every step I will be showing here will be identical for a more challenging CA simulation. This case is a tutorial case from SU2. In this particular video, I will be showing you how you can perform design of experiments using the LHD algorithm that addresses the question of where to add the sampling points in the design space and how many points to consider. For a continuously varying parameter, a space filling design such as LHD is believed to be the best. Please note that this applies even if one parameter is constrained by the other. These are the input parameters that I will be using, and column 2 and 3 gives the bounds which I'll be specifying while performing the DOE. Two variables are angle of attack and Mach number. The third variable is the free stream pressure. Free stream pressure refers to the pressure of the fluid before it interacts with an object or a surface. So it represents the undisturbed pressure of the flow. So a change in the free stream pressure indicate a change in altitude or airspeed. So since we are doing trajectory plotting, we are considering this parameter. So with this, I will shift into the SmartUQ software. So this is the UI of SmartUQ, and here I'll go to the DOE and go to LHD. With LHD, if the initial simulations do not deliver the required accuracy, you cannot add a single sampling point. The entire LHD has to be redone. So there are two ways that you can address this. First one is with the sliced LHD. The sampling points added in LHD are completely orthogonal. That is, you can rest assured that there will be no repetition of the same input parameters. So each slice we create are orthogonal to one another. So I will explain more on this once the DOI is created. The second option to address this is the design augmentation. So you select the DOE that you have created here, and then you specify the additional points that you want to run, and this will be added to the existing DOE. But I will be going with the first option here. So I'll go back to the DOA menu and I'll select the sliced LHD option. Here I will specify the number of input parameters, and here I will specify the name, and here I will be specifying the bonds. So for the free stream pressure it is 101,300, then this is 0.5 to 9.5, and for mark it is 0.8 to 2.5. Next is to specify the number of slices and the number of runs per slice. So I'll be taking 25 slices and 15 runs per slice. This is to be on the safer side because, as I mentioned earlier, if the initial simulation is not accurate, I cannot add a single LHD sampling point. So as such, I have gone for a large number, but it doesn't take any extra time. As you can see here, it will create the DOE in a matter of seconds. Now, coming to the very big question, that is, how many DOE points to consider initially? So a rough estimate SmartUQ suggests is to take 10 points per input parameter, that is as a starting point. So I have three input parameters here. So I will take the data from the first two slices and I will take that to SU2 for solving it. So you may have a question as to why I gave 15 runs per slice. So the reason is initially the recommended runs is 30 for my case. So if it is not accurate enough, I don't want to do another 30 simulations. I would like to do less simulations and add it to improve the accuracy. So this is the reason I selected 15 runs per slice. So as I mentioned, if the 30 simulations doesn't give the required accuracy to me, what I'll do is I'll take the data from the third slice and I'll take that to SU2 and solve it. Then I'll take the data from slice 4 and so on till I have a required accuracy. So I will be talking more about the accuracy and how you can determine if it is accurate or not in the upcoming video. Now I'll go to this visualization to visualize the DOE points. Just expand this, and let's say if I only turn on slice 1. So you can see that it has spread out over the entire sample or entire design space. So if I turn on slice 2, so you can see that there are no repetitions at all, as I mentioned earlier. So this will be the end of the first video, and in the next video I will talk about the shell script we use to run SU2, then load the result data to SmartUQ to create surrogate model or emulators, then check and improve the accuracy of the emulators. So if you have any questions on what was shown in this video, drop us a comment in the comment section or email us at support@k4metrics.com.